Next presentation is about the mobile digitizing at ease. And at that time, I will do it together with my colleague and partner, Kai Vogel. We will talk about this fact, mobile digitizing at ease. Okay, so what it is about, just a quick glance. There is a lot of benefits you get by this easy technology that we are using now. Yeah, it's fast, reliable digitization of templates. It's really a simple and flexible solution. And the trick is a smartphone camera is enough to do the job. Modern barcode scanners that have an Android operating system on, if the camera is good enough, will do the job as well. Sometimes you don't want mobile phones in the factory, so that's the other possible solution. There's no calibration required, and we are able to take out the distortions out of the picture and get very quickly a DXF export for further processing in an accuracy as we detected so far with all installations we did in the area of 1 millimeter per meter. So that's roughly in a nutshell and very quick the main things to know about it. It was a joint venture done with two companies, and one of them is Viprotron, Kai.
Exactly. So we started a cooperation already, when was that, Klaus? I think 4 years ago, 4 or 5 years ago, we started this kind of cooperation with the idea to use a smartphone camera for doing the inspection, not inspection, the measurement of the templates. So we as Viprotron, we are today, just a brief introduction, a technology leader for the glass inspection systems in the market. So we have more than 500 inline inspection systems, and we are working almost since 20 years in the glass processing industry with our machine. So that's why also A+W came to us, because they knew us and asked us if we can do here something together.
Yeah, so we joined our forces. I think you know us. We are 40 years in the market, and we are used to work together with partners and make use of these partnerships. So let's see what the product actually that we generate together is about. And we have several parts of it. One of it is the image processing itself, Kai.
Yeah, so the image processing itself comes from our side. So there you can see a quick example. How does it look like? Actually, the challenging part here is definitely that a mobile phone camera does not give really a good image in a way which you can handle. This is challenging part regarding the calibration at the end. And but we found a method to do that. And so what we are doing now is we are extracting the contour from the template. And we are then generating out of the template an I-shaped container, which will be sent straight to the cloud.
Yeah, and this container contains the undistorted image, and it contains a dot cloud around the perimeter of the image, which can be processed further. What we did was, clearly, when you want to use a mobile phone or a scanner, you need an app. So it was our part to write actually the app on the mobile phone, which guides the user through the process of taking the picture, and which also, what you will see later, gives the user feedback, because just taking a picture and sending it somewhere and then hours later getting the information the picture was not good enough is not really a good idea. So the app is also used to give some feedback. You will see later how that actually works. And the next part that came from us is our CAD system, the A+W cut designer, which takes this I-shaped container and then does something that we do also since ages, converting dot clouds into arcs and straight lines, because glass processing machines can do only arcs and straight lines, and you need to convert the dot cloud with thousands of points around the contour into a series of arcs and straight lines, best reduced to as low number as possible, because the lower the number, if the template is a rectangle with an arc, you would like to have 5 segments and not more. So reducing it to the best so that the machine performance is also accurately working. And in our CAD system, you see it like that. I come to that also later in a minute in a bit more detail. So what is necessary to do it?
So necessary to do is when the template was set up, that on the template such kind of L rulers needs to be placed. The L rulers are necessary that the image processing is able really to define the distortion which comes from the optics, but also it is necessary to use these kind of L rulers to avoid the intelligence of the camera image processing itself. So usually these kind of smartphone cameras, they are so intelligent, they're trying to reduce the distortion already, but not in a way how we would like to reduce it or how we need to reduce it. So it's just for your optical use when you make your own pictures. That's why we have to overcome this kind of situation. And therefore we develop this kind of L rulers, which has to be placed on several kind of positions of the template. So that's why we have different kind of sizes. So depending on the size of the L rulers, so we have to have small sizes, we have medium sizes here, and then there are even really big sizes, XL sizes, or extremely small sizes, which has to be placed always around the contour, the template, and then we are then able to calibrate the system automatically and generate the contour independent of the distortion. So.
Okay, and as you might have seen, we also found out that we need left and right-handed ones because the contours are sometimes really complex, and to get into the corners, it's often nice to have them in both directions. To show you the process that actually happens, what the user has to do and how quick it works, I have a set of images now on the next slide. You see, the typical thing is somewhere maybe in a subsidiary, not in the main production site, but hundreds of kilometers away, someone jumps in with the typical template. So that is a wooden piece, carpet piece, a piece of paper or something like that. It just jumps in, and there's a need to do it. And then there the picture is taken. But these things here, they often look like that. I think you know how they look like. If you look here, that is even more difficult, because that is something that is about 1 centimeter in thickness, yeah, which causes problems. And it's made of 2 parts. If you look into the detail, then you see that it's set together by 2 different things. So these are the real world things you have to cope with. And why I say thickness is a problem, you must see the image that you take from the camera. It looks at that level. And the corner 1 centimeter behind, if you just have the reference in the back and not in the top level, you have this 1 centimeter distortion, which by itself gives you a millimeter or more distance. So the advantage of the L rulers having as a reference object in the plane that you want to map, that is a real advantage to have it there. And that's why we do it this way. So having done that, then this image on the phone is then sent to the cloud, what Kai explains. So it goes to a cloud process where it is processed, and the image that is generated there and the container is fed back into the iPhone, and then inside the phone you'll get a contour like that running around the shape, so that immediately looking at the phone you can see whether your picture was well done or not. So you have a direct feedback. and the quality rating. We come to that also in a minute. So this is the first part of the process. And then when this is done, this image goes back into the phone or into the scanner so that you have it there. And from there, you are able to send it to the processing site where a CAD system is located. So now, once it is on the phone, you can use Dropbox or on iCloud or whatever to share it or send it via mail. This container containing everything into your shop floor, where on the shop floor, this container containing everything is then sent into the CAD designer. Then the big advantage here is that inside the CAD designer, you get as a background the undistorted image, scaled in the right dimensions, and the resulting outer contour that the system has generated. So you can easily directly see and zoom in, see how good the contour matches the image. And you can, if you want, see that this corner here, it was wrong that it is round. If you wanted to have a sharp corner, then easily to just take out a few segments, close the corner, so you can play with it. But you play with it with the undistorted image as a background, which makes it very easy. And another thing that is also interesting is if you have inside contours and things like that. I come to that later. But then having this, the next step is clearly you generate code for the machinery, or you send it to an optimizer, and then finally to a cutting machine, and then it's there. The whole thing, half an hour is long, could be quicker. And between on the left side and here, there could be 1,000 kilometers, not a problem, because one is taking the picture, the other doing the processing. No need anymore to move these templates around in the field. It's just maybe even on the construction site. That's easy to handle and quick. That's the basic idea behind it. Okay. So now, then it's handed over to the customer. Good. Well, we have 5 minutes, huh? Yeah. So then maybe some guides here, typical pictures.
Yeah, actually, these are typical pictures to make the picture how to hold the template here. So they are just examples that you just take screws to put it on, or to have a back wall which is a little bit tilted. So these are the things which make sense when it's slightly tilted. Or then what is also possible, that you stick it here with a double-sided adhesive tape directly onto the wall. That would be ideal. What you definitely not should do is to stick it here with tapes, as you can see here on these sides. And the same thing is when the tape is then covering one of those dots. This is also not allowed. But the good thing is you always get a feedback straight from the app directly when such kind of failure appears. Another thing, what is also possible, that you stick it with pins, but sure, it needs to be flat pins and not this kind of solid pins to avoid any kind of shadows.
Okay, so that's the process and some examples how it's actually used in the factory, and some examples to solve the problem that people say when the glass is large. Normally you take it on the floor and you take the picture from above, but at some point in time it gets too high and then you need a step ladder and things like that, so you need to fix it on the wall. And there are several solutions our customers so far found how to actually do that. But just one word again on feedback. After we understood now a bit how it works, a crucial point is to understand, is the picture I took right? Because you would like to give it to a worker in another field that does the picture, and you don't want to phone all the time, please hold it like that or like that. So we try to get a feedback rate, and this feedback rate gives you a confidence factor, and it also gives you hints. There are several rules. For example, the rulers should be placed as close as possible to the contour, because clearly the rulers, they are accurately known. And by the way, these rulers we delivered, Viprotron delivers them. We have a source to produce them because they have to be very, very accurate. We found out that a distortion, an error in the ruler, multiplies by a factor of 10 into the final result. So if you have 1 millimeter problem here, you get 10 millimeters in the end. So that's why they have to be really accurate, and they also have to be stable against temperature, extensions, and things like that. So there are some rules to do that. Easy to handle, but still to keep in mind that this is important to know. And that's why we get this feedback. The feedback gives you an information how many rulers were detected. So say you put 5 rulers on and only 4 were detected, clearly you should redo the picture. Because why losing 1 ruler that gives you more information on the background than skipping it? So that's one thing. And the confidence factor, that is something we compute basically based on the idea that based on the undistorted picture, we calculate backwards to the rulers and see if we then find them again. So we have a match, and we see how close we are with the rulers to the contour. And all these together gives a confidence factor. And at 60%, I would say, please do redo the picture. When there is 90%, in the later versions of the app, we have a color scheme, red and yellow and green. So that is very quick to see, picture good, I send it or I redo it. That's basically the idea. And if the confidence rate is not good enough, use more rulers, move the rulers closer to the contour, and maybe change the light conditions or change the background and things like that and redo it. But you get these hints. One more word on what you can do inside the cut designer. You see, again, that's another picture of a template done here. Where you can do corrections, but what you can do else inside Cut Designer, you can go in here and say you have maybe a template with a drill hole here and here. You will see the drill hole in the undistorted picture. And as this is an undistorted 2-scale picture, you can just use the features of the Cut Designer and draw the drill holes here, and you have them in your result with just a few clicks. So even that is possible. In a later version, which will definitely take some time, we are working on an idea to automatically detect the inside contours as well. It's not so easy. And then in that case, this result would already have the marks around there. But today it's already possible by just taking the undistorted picture and doing it. Yeah? So, in summary, yeah, we have a fast and reliable digitizing method, very easy to use, extremely flexible, with a smartphone camera or a digital scanner, so tools that you have at hand. And no calibration is required due to this trick, which is also in the layer on the pane, on the surface which we want to detect. So no problem when your templates are very thick, it's doesn't make a difference. So everything fast and quick. And it shows that a strong partnership can provide really good solutions. Thank you for your understanding.
Thank you too from my side.